Solve some problem. Okay, so now let's solve some problem related to your Newton's law of viscosity, but I have took some interesting problem only. Most of the problem you will get, put the formula, get the answer. You know our formula. What is our formula? Tau is equal to mu v by y, or F is equal to mu a v by y. Mostly, these are the formula with respect to Newton's law of viscosity we'll be using. Okay, so but I have took some interesting problem. So all are previous year gate questions. Okay, so we are actually discussing previous year gate questions. See, this is quite interesting. Okay, on the first attempt you may not find it as a fluid mechanics question, but it is a fluid mechanics question. Okay, so see this. It has told that you have a cubic block. This block is cubic. What is length? L. Its length is having L. Okay, so its area is L square and volume is L cube. Got it? So this block has a mass of capital M. Okay. Now this is resting on a surface which is having some fluid over here. Correct. The viscosity of the fluid is mu and the fluid is at the height of h. In order to reduce friction, obviously you use grease, right? Lubricating oil. Some lubricating oil they have given which is having a dynamic viscosity of mu and the thickness of the lubricating oil is h. Okay. So now there is a stainless pulley here. On the pulley, on the other side of the pulley, there is a block of mass m. Okay? There is a block of mass m. Now the question what they are asking is, what is the expression of steady state velocity v of the block? So normally, these questions are a little tricky. Why tricky? Look at the options also. In the option there is capital M, small m, capital M, small m. So you need to be little, you need to have a clarity before you are solving the problem. So let's see the equation here. This is a rope, so we are having a tension over here. Okay, that is T. Now let's draw the free body diagram of this. If I draw the free body diagram of this block M, which is acted upon by a T and gravity G. Correct? No sir, we don't know whether it is heavier, whether it is lighter, what if it pulls up or pulls down. Just a minute. For that we have a acceleration mn, isn't it? Okay. So now apply Newton's second law. F summation of F equal to ma. That is here T minus mg is equal to what? M into a acceleration. But what they have said, steady state velocity. That is your velocity is constant. If your velocity is constant, what happens to your acceleration? 0. If your acceleration is 0, what happened to this term? It became 0. So this implies your T became your M into G. So now this confusion over. You are going to use the small m. Okay. Now apply your Newton's law of viscosity here. What is Newton's law of viscosity? F is equal to mu into A V by Y. Okay. So this implies here is nothing but the tension T is equal to mu. What is A? What is the base area? L square into the velocity. Okay, velocity is your v divided by y. Y is nothing but your h. Y is nothing but your h. So what is your t? T equal to mg na. What is your t? T is equal to m into g is equal to mu. We got it here, right? L square into v by h. What expression they want? They want an expression of steady state velocity v. This implies v equal to mgh by mu L square. That is which option? That is which option? Option C. That is option C. Thank you. We have one more interesting problem here. Okay. Initially, you might think this problem is from machine design or somewhere, but you cannot solve the problem without the help of fluid mechanics here. Okay. See, this problem says a lightly loaded full journal bearing has a journal diameter of 50 mm. Okay, mm में दिया है diameter. Bush bore of 50.5 mm. Bush length of 20 mm. If the rotational speed of the journal is 1200 rpm and the average viscosity of the liquid lubricant is 0.3 pascal second, find out the power losses. Okay. Okay. So power involved, torque involved, sir. So it's not a question of fluid mechanics. It's a mix. It's a question of fluid mechanics and machine design. GATE is very famous for this. They'll mix the question from fluid mechanics, machine design, strengthometer, mechanics. Okay, heat transfer, fluid mechanics, something. they do it. Okay. So what the prerequisite for this problem is, see, what is my power? Power is the omega t. Okay. Omega what? Angular velocity. T is the torque. Torque means what? F into R, force into radius. Okay. Force in this case, for this problem, my force is nothing but the shear force. And from the Newton's law of viscosity, we know that F equal to mu A B by Y. Okay. Where B is the velocity. So as here, speed everything in terms of angular velocity, but my v is the linear velocity. So I have to convert the angular velocity in terms of the linear velocity, hence v equal to r omega. Okay? And your angular velocity is nothing but 2 pi n by 60, where n is the speed in rpm. Speed in rpm. Omega, angular velocity in radian per second. What is the formula? V equal to r omega. Omega 2 pi n by 60. 2 into r is nothing but the diameter. 2 times the radius is the diameter. So V is also known as pi dn by 60. We can also be written as pi dn by 60. With these prerequisites, we are going to solve this problem. It's a GATE 2010 question, 2 marks question. So, ध्यान से देखो and step by step देखो. First, let us understand this question. What actually this question is all about and what it is trying to tell us. So, there is a, this bearing bush. What is the diameter of this? So the diameter of this is 50.5 mm. Okay, everything is in mm. Maximum, all the diameter, everything is in mm. Okay. So inside this, there is a journal bearing which is rotating. Okay, which is rotating. Okay, rotating at a speed of n equal to 1200 rpm. Okay. What is the diameter of this journal bearing? The diameter of this journal bearing is 50 mm. So now imagine this, imagine like this. So this is your bearing. This is rotating inside your bearing bush. Understood? Now it's rotating like this. Okay. So what happens? There may be a friction. There will be a friction. Heavy amount of friction. In order to avoid the friction, between this clearance space, we are using some lubricating oil. We are using some lubricating oil of viscosity 0.3 pascal second. 0.3 pascal second. Okay. So what is the thickness of this? What is the thickness of this? Come on. What is the thickness of this? कहाँ पर है ये? See, this thickness is this one. That is your annular space. That is the annular space. Okay. So that's how we'll be writing here. So we'll write now given data here. Okay. Let's write given data. What are available? Sir, diameter D is given. कितना दिया है भाई? 50 mm दिया है sir. Okay. Convert it to what? Convert it to meter. Everything you have to write in terms of SI unit only. Everything you have to write in terms of SI unit only. So this implies what will be radius? Half of diameter. So 0.025 meter is the radius. See this annular space, that I need C or Y. That is the thickness of the what? Thickness of the your lubricant. Thickness of the liquid lubricant. Capital D minus small d by 2. This minus this by 2. Then only I get these areas. Understood? Okay. ठीक है? तो how much is this? 50.05 minus 50 by 2. That is 50.50. 0.50 by 2. That is 0.025. What you got? Mm. That is 0.25 millimeter. Okay. Sir, convert it to meter. Okay. 0.25 into 10 to the power minus 3 meter is the C or Y. समझ में आ गया? Understood? Length is given. कितना दिया है लेंथ भाई? लेंथ कितना दिया है? 20 mm. सर आपने डायग्राम में ज्यादा ड्रॉ कर लिया है. It's not at all looking like 20 mm. Okay. ठीक है, not to scale हो जाता है. ठीक है? 20 mm. That is 0.02 meter. Length हो गया? ठीक है? So let us calculate the velocity then. At what velocity it is moving? Velocity v. That is pi dn by 60. Pi D, how much? What is the diameter? 0.05. N is your 1200 rpm divided by 60. So what is the velocity you are getting? Come on. What you'll use to calculate? You have to use the gate virtual calci. See, if you are writing gate exam, virtual calculator is very important. Otherwise you'll do mistake. If you are not practicing here, it's waste. अगर ये कोई practice नहीं करना है तो देख लेना, एग्जाम में पंगा हो जाएगा. ठीक है? तो पाई into 0.05 into okay 1200 by 60, that is 20. So how much is my velocity? What is my velocity value? My velocity value I am getting is see 3.14159 meter per second. This is the velocity I am getting. Okay, this is the velocity I am getting here. What? Linear velocity. Now I have converted the angular velocity into the linear velocity. So now let's go for this problem. So it has asked us power. Very good. Power is equal to omega t. Now tell me what you know. Do you know omega here? No sir, we don't know omega here. So calculate omega. What is omega? 2 pi n by 60. Okay. So 2 calculate. See 2 into pi into n by 60. So merely you are getting 125.667 what? Radian per second. Radian per second. Now t sir, how to calculate t per? T is equal to f into r. Sir, do you know f? No sir, we don't know f. We have to calculate it. Do you know r? Yes sir, r we know. R is 0.025 meter. Okay. So for calculating f, Newton's law of viscosity, mu a v by y. What is mu? 0.3. What is a? We don't know. What is v? 3.14159 divided by what is y? Y is this value 0.25 into 10 to the power minus 3 goes up 10 to the power 3 here. So what we don't know here? A. Now calculate it. Sir, A formula. First. Pi by 4 d square. No. See, this is where your area, types of area becomes important. In fluid mechanics basics, I have told you there are so many types of area: cross-sectional area, surface area, projected area, crushing area, bearing area, tearing area, normal area, developed area. Okay, so sir, is this all areas we need? No. We will be needing mostly two: cross-sectional area and surface area. See, it based on the problem actually. In this problem, what they ask? देखो, ये है तुम्हारा जर्नल जो इसके अंदर घूम रहा है. So you tell me, your lubricant is on the surface or inside? It's on the surface, right? The lubricant is helping to prevent the friction between the surface of your bearing and the outer surface of the bearing and the inner surface of the journal. So where it is acting? Where it is acting? On the surface. On the surface. So that's why we'll be using what? Surface area. What is the surface area of a cylinder? Formula pi d. Pi d is 0.05, L is 0.02. So how much you will get the value? देखो 5 to जाता है. You may get 0.00. We'll see. Pi into 0.05 into 0.02. How much you are getting? 0.00314159 meters square. ठीक है? Use the same value here. यहाँ पर डाल दो 0.00314159. Okay, area. So after that, calculate f. How much is your f? After this all formula, how much is your f? Come on, tell me what is the answer you are getting. 3.14159. You can pause the video and you can calculate. Okay, what I am getting force is 11.843515 Newton. This much I am getting force. Now use this force 11.84351 into your R, that is 0.025 into 0.025. How much you are getting your torque? How much the torque you are getting? 0.29608 Newton meter. What is the unit of torque? Newton meter is the unit of torque. So once you got omega, once you got torque, put that value here and calculate power. That is 125.667 into 0.29608 which is nearly equal to how much? 37.208 watt. ठीक है, power unit is watt. समझ में आ गया? Interesting question. This question was a mix of what? Your fluid mechanics and machine design. So you have a bearing bush. Okay. In that the diameter is 50.5 mm. In that you have a journal. The journal dia is 50 mm. The journal is rotating inside this. Okay. Your bore, bush bore. Okay. So that's why there may be a chance of getting friction. There will be a chance of friction once it comes in contact with that. So that's why in order to avoid that we are using a liquid lubricant. The liquid lubricant diameter, so the thickness of the liquid lubricant is this, what we calculated 0.25 to 10 to the minus 3 meter or 0.25 millimeter. Okay? So then we use this formula and calculated power omega into T. Omega T F into F mu A F is known as backward substitution method. This is known as what? Backward substitution method. See why this becomes very important here. In GATE, this is a 2-mark question. As it is a 2-mark question, okay, you have around 3.6 minutes to solve this problem. There is a strong chance that if you directly put the formula, everything in one go you will try, there may be a chance you will miss between 0.003149 and 3.1419. Okay. Otherwise, instead of 0.025, you will write 0.25. So that's why you have to do step by step. Take some time. One time only you do, but you make sure that you do it fine. Understood the problem? It's a very, very good problem, isn't it? One more problem. Okay, this problem has come in Mechanical GATE 2004. Okay, so what it has said is an incompressible fluid. It has given kinematic viscosity of this and its specific gravity is given. Here is held between two parallel plates. If one of the top is moved with a velocity of 0.5 meter per second, the top plate, while the bottom plate is being held stationary, fluid attains a linear velocity profile, the gap between 0.5 mm and shear stress in the Pascal they are asking. Very, very, very Newton's law of viscosity question. Okay, simple question, nothing else. So we'll solve it. How we'll solve? First write given data. Okay, properly. What is the given data? Kinematic viscosity. Sir, nu has been given 7.4 into 10 to the power minus 7. Which unit pa? Which unit? Come on. SI unit it has been given. Specific gravity is given 0.88. So what is density? What will be density? Specific gravity into density of water. If you remember our formula, what is specific gravity? It is nothing but density of matter by density of water. So density of matter became specific gravity into density of water. So here S into density of water, that is 0.88 into multiply by 1000 and you got how much? 880 kg per meter cube. Okay? Then what they have given? Velocity given, V. How much is the velocity? 0.5 meter per second. Need not to worry, this is already in SI unit. Okay? And the fluid attains a linear velocity profile in the gap of 0.5. Y is given 0.5 mm. Now you convert into meter. 0.5 into 10 to the power minus 3 meter. See, you need to understand, there is a plate here. Okay? There is a stationary plate here. This gap is 0.5 mm. This particular thing has been moved with a velocity of 0.5 meter per second. Okay? This is the movable plate and you have some fluid here. This fluid has a nu of 7.4 into 10 to the power minus 7 and its density is 880 kg per meter cube. Specific gravity is 0.8. 0.88. Understood? So now they are asking what is the shear stress. So from our Newton's law of viscosity formula, what is tau? Tau is equal to mu V upon Y. Sir, mu we don't know, but we know the formula. What is the formula of mu? The kinematic viscosity is nothing but dynamic viscosity by density. So your dynamic viscosity becomes kinematic viscosity into rho. So use the formula here. So this implies tau is equal to nu into rho multiplied by V divided by your Y. This implies tau is equal to, come on, tell me the value. Yes, how much? Mu equal to 7.4 into 10 to the power minus 7. Density is 880. Okay, times the velocity. Velocity is 0.5 meter per second divided by Y is how much? What is that there? 0.5 mm. So 0.5 into 10 to the minus 3 meter. So here I am writing 0.5, here I am writing 1000. Okay, now let us calculate how much you are getting. Use your calci. Again I am telling which calci you have to use. Virtual calci. Okay, 7.4. Come on, 7.4 into 880. This is 1. Cancel. Okay, how much you are getting? I am getting 6512 into 10 to the power minus 4. Okay, that means divided by 0.6512 Pascal. Where is the option? Option B. Yes, correct. You understood the problem? Huh? What we have done? Come on. What we have done? Okay, we have a plate here, moving plate. We have a stationary plate. The distance between them is 0.5 mm. This is being filled with some lubricant liquid. What is the kinematic viscosity of the liquid? 7 given is the specific gravity. We know specific gravity, density of matter by density of water. So density of matter equal to specific gravity into density of water. Hence 0.88 into 1000 is 880. Mu is given 7.4 into 10 to the minus 7. We know mu is equal to mu by rho. Kinematic viscosity equal to dynamic viscosity by density. Hence dynamic viscosity is kinematic viscosity into rho. Rho is the density. And we put the formula here. Okay, and we got the answer 0.6512 Pascal. Got it? We'll go to next problem now. So this is one more interesting problem came in GATE. Okay, see what they have told is there is a kinematic viscosity of air at 20 degrees Celsius is given to be 1.6 into 10 to the minus 5 meters square per second. So what will be its kinematic viscosity if the temperature is increased to 70 degrees Celsius? They have asked. Okay, now see our mu is equal to what? Kinematic viscosity mu by rho. Mu equal to mu by rho. If you have gone through my all videos properly, you could have known कि sir mu is proportional to square root of t. Sir कहाँ पर लिखा था sir? Mu of gas. If you remember, I have written mu of gas formula b root t by 1 plus a by t. ठीक है? तो mu of gas is nearly proportional to square root of t, and the density of air is inversely proportional to t. While if we increase the temperature, what will happen? Its volume also increases. This implies density, mass by volume. Volume increases, so density of air decreases. Okay, simple thing. देखो, आप heat कर रहे हो, gas expand हो रहा है, more volume occupy कर रहा है, more volume occupy कर रहा है, density is decreasing. ठीक है? So rho of air is inversely proportional to your time. So this implies mu what will happen? Mu is proportional to t. Okay, because of mu is proportional to square root of t, and density is inversely proportional to t. So combine karo, mu is proportional to t into root over of t. That is mu is proportional to t to the power 3 by 2. I want to apologize. T, and I think one of the slides somewhere instead of mu I have written mu, I think. Okay, in that topic. ठीक है? So वो correct कर लेना. So mu is proportional to t to the power what? 3 by 2. So अभी formula डाल दो. What you need? Nu. So nu2 by nu1 is equal to t2 by t1 to the power 3 by 2. So now be careful here. I'll tell you why. Nu2. So this implies your nu2 is equal to nu1 into t2 by t1 to the power 3 by 2. So nu1, what is the value of nu1? 1.6 into 10 to the power minus 5. Now T2, sir, T2 is 70. Wrong. That is 70 degrees Celsius. You have to write in Kelvin. You have to convert that into Kelvin. गलत हो जाएगा नहीं तो पूरा गलत हो जाएगा. ठीक है? तो convert into Kelvin. 70 degrees Celsius. What is the Kelvin formula? हाँ, come on. Degree absolute or Kelvin equal to T plus 273. 273 में ऐड करना है. T degree Celsius. और डिग्री सेल्सियस प्लस 273. So 70 plus 273 how much? 343. So 343 divided by T1. How much is a T1? T293. Now solve it. Come on, take your virtual calci. Remember to use virtual calci only. Don't use any, your normal calculator. That's not allowed in GATE. So 1.17 to the power 3 by 2. So here is your power symbol. Okay, x to the power y. Go here. 3 by 2 is nothing but 1.5. Use it. How much you got? 1.6 into 10 to the power minus 5 multiply 1.2 double 6. How much answer you are getting? You are getting 2.02656 into 10 to the power minus 5 meter square per second. So what is your answer? Okay, this is the answer. 2.2, 2.02 actually. This. Okay. So look at this problem. We needed. So this is an improvisation problem, kind of an analytical problem. We have in our course, we have studied rho independently. We have studied the variation of mu with the temperature independently. Now here what they did, they mixed the problem and they gave you a question. So that's why you have to be very thorough with whatever subject we are doing. You have to, go through entire topic what we are discussing. You understood, right? Mu is inversely proportional to T, directly proportional to root over of T, rho is inversely proportional to T. So you got your mu is proportional to T to the power 3 by 2. Don't forget to convert degree Celsius into Kelvin. Okay. So with this we have come to an end of viscosity. Okay, your topic viscosity and some Newton's law viscosity problems we have solved. I have chose only some variety of problem. There are so many questions you can solve which are very easy. All will be based on tau equal to mu v by y formula or f equal to mu a v by y formula. Remember not to mess with the area. Check whether it's cross section area or surface area. In maximum cases it will be a surface area because your lubricating oil will be on the surface. You understood? Don't make that mistake. Okay. So I am open for any constructive feedback. Okay. Or please do comment your doubts or what you like or what you don't like and what are the areas of improvement you like in this approach of mine. So please let me know in the comment section. Right. Thank you. See you in the next class.